Hello, everyone. Thank you for joining us for today's OEM COG webinar. My name is Megan Jones. I'm the Executive Director of ICEA. Just a quick note on housekeeping. If you have questions for our panel today, please put them in the chat and we'll get to those at the end if time permits. And with that, I'm going to turn it over to the OEM COG's Sandy Burney, who's going to introduce us to our panelists today. Sandy?
Thank you, Megan. I'm Sandy Burney, and I'm part of the, call it the steering committee of the OEM COG, which is a subgroup of ICEA. And we've been trying to put on a quarterly webinar. Plus, we are going to have a forum prior to the workshop, and I'll discuss that about that a little bit later. And so today we're going to talk about some production costs. And we have Fred Beck from Booz Allen and Tom Shanahan from ProjStream, who's going to start us off today. Thank you.
Thanks a lot, Sandy. Yeah, so today we're going to talk about how to better estimate and forecast production cost. So the main idea is we're trying to get across is using your own data to produce data-driven defensible estimates. So one of the more common things we have in conversation with new prospects and folks that we talk to is, how much does something cost? In other words, how much labor or touch labor does it take to produce or manufacture something given a bill of material and the labor associated with it? Sometimes there's uncertainty also on support costs, which Sandy will talk to here in just a minute. And then from that point, once we're able to retrieve the historicals, which is sometimes hard to get to, what does something cost? What does that first unit cost? And then is there a learning curve associated with that? And then how do I apply the learning curve factors from, the first unit to the nth unit? So we've been talking a lot, and from a cost estimating and analysis standpoint, estimators know how to solve these problems in theory, but in practicality, the problem of getting the data sometimes is pervasive. So today, we're going to try to look at that problem, why that problem exists, the depths and dimensions of that problem, and some practical ways to maybe look at solving them. So we feel ultimately the goal should be right, and Fred, who's on, can attest to this, is to try to get that data into the knowledge workers' hands or, more accessible so that they have more validation or data to work with. So a little bit about housekeeping. We got 45 minutes, and then we're going to open things up to Q&A. So like Megan said, put anything you have in the chat, please. We'll save those questions till the end, and we'll get started. So here's a little bit about the agenda, what we're going to talk to. Fred is going to open us up with the pains and challenges in the industry and, both estimating and forecasting, because this is not just an estimating problem. It's when we get into execution of the project. Sandy is primarily going to talk about the learning curves and the theory, and also some additional considerations of production cost estimating, because it's not just touch labor, it's sometimes the support you have to consider. And then I will address the real-life production cost estimating, it being a data problem, looking at some of the historical data and how to manage that, some ideas about how to think about setting up for homogeneous items. And then, once we've done that, how can we templatize that data and set up libraries maybe to reuse some of that data? And then ultimately just look at a little bit about forecasting and that being part of the problem as well. And then Sandy's going to end it with a quick data example. So with that, I would like to introduce Fred Beck. So a little bit about Fred. Fred is director at Booz Allen Hamilton. Currently, he brings over 35 years of detailed experience developing strategic cost estimating for DoD, IC, and commercial customers. He's developed complex solutions and associated cost models for mission-critical systems for launch, ground, SATCOM, missile defense, space, domain awareness, and other space missions for a broad set of commercial and government customers. During his career, Fred has created and managed high-performance teams excelling in all phases of the program lifecycle, from early business development through contract completion, while specializing in the development and capture of new business. So with that introduction, Fred, tell us a little bit about the pains and challenges that you've seen in the industry.
Thanks, Tom. I think I get the easy job here. I get to talk about the obvious. I think most people on the call have, who've done estimation in the past have run into issues, and I've tried to bin them in three different primary areas. But just like a battle plan, when you go to war, it doesn't survive contact with the enemy. And the fact is that any estimation that you do for production type systems doesn't survive contact after ATB. You have a lot of things that change. Your original design, your bomb that you developed, even your labor estimates against that bomb and implementation, they diverge, and they diverge for a lot of rational reasons. Supply chain issues, parts acceptance issues from your quality team, not getting the quality parts that they need, and I like to say part supply too, because outside of the supply chain, you might have situations where parts have been revved and you're unaware of it. You get the updated rev that you ordered, the last rev worked fine and the new rev doesn't. And so there's a lot of these things that force you to have to go back and affect and diverge from your original estimate. Also, the previous configuration that you designed to may have been designed to a different set of requirements than you're currently trying to estimate against. And so it's not from an analogous approach, it's not a pure one-to-one mapping of parts or estimation approaches. And then you have other issues. You have long lead items that come into play. You have GFE. I don't know if anybody on the phone has ever had GFE delivered on time and that have met all the requirements that you anticipated from it. But those kind of things can affect your overall system that you've estimated, and these limit your ability to standardize data that you're trying to use from a data-driven kind of approach, and provide that defensible estimate, and be able to what do I want to say? Execute under the budget that you've allocated. And so it's important in those kind of aspects to make sure that you've got some margin built into those estimates. And sometimes you're allowed to do that on proposals, and sometimes you have to figure that in as a way to make sure that you can execute and not expose risk there. The other issue that Tom alluded to is data capture. Often, companies will keep their labor data over here and their material data over here, ODC someplace else, and it takes immense to go and find that data and be able to tie it together. And often the people doing your estimates may or may not have access. But those relationships between the material and the labor, often you end up having to go back to engineering judgment and poke Susie or Joe on the shoulder to find out exactly what they did during execution to be able to tie that back and close that loop. And so storage in different locations and different systems and access issues, and sometimes just making sense of it can be a challenge. And then you've got the old trade studies that take place. Those from an engineering perspective are great, but they're just another change agent on your assumptions that you took into your estimation up front. They may decide you might have planned for the highest cost or most taken a conservative approach on the outcome of that trade study, but the trade study ends up going sideways and comes up with a completely different design change that forces again yet another perturbation to what you've estimated. And these situations cause a lack of overall visibility to the data that you've collected and its usefulness for future estimates. And then finally, the knowledge learning. Like I've already alluded to, sometimes the actuals don't always map back, and their usefulness is less than perfect. And so for that reason, a lot of folks in the industry will develop cost estimation relationships that tries to normalize or take that actual data and literally drive a line through it or a curve through it so that you can kind of normalize, use a parametric approach or an analogous approach based on your alignment with actuals to try and minimize some of these divergences. Because as you get more and more data together, it kind of normalizes out. And then, we also tend to rely very heavily on subject matter experts. And while, the engineering estimation is viewed as the least desirable approach for us estimation, it often is relied upon to try and make sense out of this data. I like to call those SMEs heroes, because no one, starts their proposal or their effort soon enough, and you end up working hours or late nights and weekends and holidays, and these heroes have to come in and try to make sense of data, provide a defensible estimation. And the other aspect is, you get all done and you record your lessons learned from this, or like we used to call it at other companies, lessons filed. And so rarely do those lessons learned actually feed back to improve process or improve the problems that you had to overcome on trying to find the data and put it together and make sense of it. And closing that loop, should hopefully provide those adjustments and refine your ability to get better estimates in the future. But that's only if you have, a solid process that can build off of that. And learning as we go forward is important. And trying to find ways to refine and improve this process. I think that's been kind of the basis of my career over the last really 37 years, is when there's a way to do things, to find ways to continuously improve upon that, so that the organization is getting better at doing this. And that requires a data-driven approach. With that, Tom, I'll hand it back to you.
Thanks, Fred. I just have a couple questions. Based on your experience and longevity at Booz Allen and Northrop Grumman, has it been you talked about the heroes, has it been your experience that they're accessing that data up front and validating it and then kind of doing the hero thing, or is it the other way around, where they're using their experience and then using the data to validate their assumptions?
Usually the latter, mostly due to the short timelines associated with the estimation window that you've got to prepare that defensible proposal. What I like to use the heroes for is to try and work with them during the development of CERs and those cost estimation relationships, and validate those in between the proposals. But often they're not available because the busy people tend to get busier within any organization. So you have to be very intentional about that.
So sometimes it's a time crunch and you're trying to get that done, and there's not always time to chase the data, but you'd like to have it for the proposal. So one more follow-up question, then we'll move on to Sandy's piece. You talked about process a little bit, and people talk about process. So talking about process, in your opinion, does process fix some of the data problems that you see, and how much does that help?
My gut reaction is to say no. The quick response, it can, but process usually doesn't take into account all the different possible variable avenues and degrees of freedom associated with estimation. If you can have that intentional process of trying to capture and apply lessons learned and refine and go forward and improve, as well as have a heavy reliance on real data, actuals recorded during previous execution efforts, and then be able to refine your estimation tools and approaches, then process can be a definite improvement. And I'm a big fan of process. Having that intentionality, repeatability on things, I think is important for not just believability, what you produce with your customer base, but also within your organization, that you've got confidence that you've been able to repeatedly produce similar kind of results that have been adapted to the problem at hand. But by itself, no. Most organizations treat process as something rigid rather than guardrails that you can work within and try and improve. But when process can be applied and nurtured and tailored, then it definitely can have an improvement.
So maybe a little bit more of a flexible approach and better access to the data could be helpful.
Yeah, the access to the actuals from previous execution efforts is extremely important.
All right, cool. Thanks, Fred. All right, we'll move on to Sandy's part. So I'm going to introduce Sandy. He's going to talk primarily about the learning curve theory. Sandy provides cost and capture strategy consulting for Northrop Grumman. In his 30+ years, Sandy has provided cost estimating analysis and government, CETA, and OEM employment. Across these three types of employers, Sandy has performed forecasting, cost estimation, and modeling within specific groups, systems engineering, capture, and pricing organizations. In the past, Sandy was a lead cost estimator on several production programs and developed cost models utilizing a combination of learning curves and historical data, cost estimating relationships involving strategy, solutionizing, and cost estimation, which is great because that's what we're about to talk about. So Sandy, you want to take it away?
All right, thanks, Tom. So the title of this slide, Learning Curve is a Theory, Not a Fact, is something that I think is a quick way to think about this whole topic that we're talking today. And I got to do a shout out to a fellow OEM COG member, Chuck Kurtz, who came up with this title as we were discussing topics for our OEM form that will proceed. That's on 3 to 5 on Monday prior to the workshop in Minneapolis. I think that starts on the 13th. But hopefully all of you will be attending the workshop and then can come also on Monday and join us for the OEM COG forum. So the reason I say this short title is because, you know, I'm not really going to teach you the learning curve theory, because that's something you can learn at the workshop, or you can become an ICEA member and read the CBOC 2.0, or Google it on the internet and read all about it. But I'm just going to touch a little bit of how the theory can be used in practice. Because overall, in today's complex world, we don't really produce things from bending metal to a finished product all in one plant where it's all touch labor. Most things today are very complex subsystems that are built by small manufacturers or some larger manufacturers and then brought together for final assembly in a plant. And these complex things really have different types of learning curve rates because they're coming from lots of different manufacturers. I'll go into that a little bit later. But generally, you could have an overall curve, and maybe that's good enough for your estimation. But generally, if you want to be more precise, you need to kind of break that down into pieces. You know, and again, learning curve theory was started mostly for touch labor. In today's environment, there's generally not a lot of touch anymore. A lot with robotics, the actual factory floor really doesn't have a lot of people, and what your largest costs are going to be your support costs. And again, a good source is the CBOC 2.0. And so the other part about theory is not a fact, again, is Tom's going to talk after this about getting the data. That is the key, is we all belong to companies, and sometimes it's easy to get the data out of our systems for forecasting from actuals, but oftentimes it's a little bit more tricky. And then to make it repeatable, one has to get often the IT folks involved, and it's a challenge. So that's what really Tom is doing, is telling you how to get the data out of your systems. And I'm going to say how you apply the data to go check this data using learning curve theory and formulas. Is there actually a learning curve, or are your parameters pretty flat? Okay, next slide. So I'm just going to go about the three major theories of learning curve. Is what this first one is cumulative, and the formula you can see is y equals ax to the b, and it really looks at the cumulative number of hours and does some analysis on that. So if we go to the next slide, which is the unit, which looks at unit cost versus the cumulative costs. And again, it's really the same formula, and how they are used, really, you need to go in and look at your data, play with the formulas in your spreadsheets and how you set things up, and see which one kind of works the best. You know, it all depends on what you're trying to estimate, and you have to be cognizant of both theories and how you apply both of them. If we go to the next slide, which is the lot midpoint, which is actually the formula I've used the most, because in my experience at Northrop, we usually were producing low quantities and lots. And so you really kind of need to do this lot midpoint when you have really low quantities of things that you buy, and especially when these productions take years. So some of the things I've had to estimate, you know, you start production and in 1 year and 3 years later, the final assembly comes out. So that kind of tells you it's a very kind of low rate, and you got to use averages over the lots, because there is learning in the touch between the first unit in the lot and the second unit and the third unit in the lot. Okay, Tom, if we go to the next slide. So in practice, for our government contracts, usually for the large OEMs like my company, our systems are really fairly complicated. If you, one of our systems that I worked on, the Triton UAV, it had many major subsystems. And those subsystems came from different suppliers. And so each supplier probably has their own cost improvement, or you try to negotiate cost improvements over time. And so if you use learning curve, you're really going to have different factors. So you kind of got to break your system into pieces if you want to get a more accurate way of forecasting what your future costs are going to be. And then you get to support costs. As I said, support costs can often be even greater than your touch. So often, to do estimation, you have a relationship of support to touch costs. Oftentimes that ratio is greater, so it takes more, you have more support hours per hour of touch. And the support costs are people who bring all they manage all the supply coming to the factory line. They take all of the pieces that come in and put them into kits for the touch folks to put together. There's the production planners. There's buyers. There can be a whole lot of cast of characters that go into your support touch costs. Again, we talked about suppliers, you know, large assemblies that come into the plant that then get put for final assembly. And then materials. So those are more like the raw materials, or even things like nuts and bolts are material costs. And material costs generally don't necessarily follow a learning curve. They're more economic quantity adjustments. So the more material buy, the better price break. So depending upon your forecast of how many units you're going to buy or how much material, you might get different estimates. And finally, there's a challenge on doing learning curves is how do you deal with production breaks? Since most of the folks here on the line really deal with government contracts, and we know how, due to government shutdowns and procurement issues, that often there could be production breaks or change of requirements or added new pieces. So you have to account for loss of learning, whether it's partial or complete. Next slide. So here's just an example of taking a complicated system, and here's how you might want to do your estimation to by these different components. So you might actually have two subsystems that are produced in two different factories or two different lines in a factory. So you might actually have, depending upon their complexity, different learning curves. So you want to get your data and break that down into your different subsystems so you could estimate different learning curve factors for each of those. And maybe they're similar and you could combine it together. It all depends on what the data tells you. And then you've got some system integration costs, which may have a learning curve. It may be flat or not. And then you have supplier costs, which, even though they look like a learning curve, usually we call them cost improvement curves, because you're looking at the total delivered type of from the supplier, which it has a combination of both touch and support and LOE, because that is their final product. And again, material can have economic order quantity factors. And then you get your support labor costs, which could be a factor of your learning curves, or could be LOE. I actually, if you're more interested in that, I actually kind of did a presentation for ICEA in 2017. So if you go into the ICEA library for workshops, you can look at my paper on when I did something on production costs and support costs, and you can see a little bit more detail. And then you've got PMO costs, which generally kind of are LOE. So you can build models that estimate all of these at different levels, or if you're doing a proposal, you might want to break your proposal costs into all of these pieces so you can get into some better detail. Next slide.
We've come to the end of.
We come to the end. Okay.
But I'm not going to let you off that easy. So I've got a question, because this comes up a lot. You know, Northrop Grumman, I'm assuming, is pretty mature in collecting data, but what we kind of see a lot is, so what would your advice be to a company that hasn't collected data, or sometimes have collected data at too high of a level, but they want to get better at estimating? So maybe they didn't collect the data as well as they wanted to. They're trying to remap it maybe to a lower level, the WBS. So they're trying to improve. So they don't really have the data yet that they want to validate the CERs or the learning curves. Can they apply the learning curve theory and then analyze it, tweak it as a kind of a work in process, or what's your thought on that?
Well, if they don't have the lower, you have to work with what you got. And so you probably want to look at the higher level and see, apply some of the learning curve theory data and see if you're getting a learning curve. Does it make sense? I mean, that's, cost estimation is more art than practice, because you have to just kind of look at what your results are and see, does it make sense? And while you're trying to work to either decompose things to lower levels, but there's a good chance that your higher level data might actually work for you. It kind of all depends. So if we have time at the end, I'm going to show some quick demonstration of some forecasting models, how I got the data, and then use that to do some forecasting in a model, an Excel model. So.
Okay. All right, cool. So I think the main point is, don't fail open. There's still ways to go and validate your data, maybe at that higher level, while you're transitioning and decomposing and getting better at that lower level. Don't just get stuck. All right, cool. So I'm going to talk about real life production cost estimating. What we see a lot of times, people come to us for these problems, and the main idea is they're not getting access to the data, right? And a visual of that. Well, actually, before I get into that, we're going to talk about the 4 types of estimates and an evaluation of a BOE, and then we'll talk about the data problem. So Main types of estimates are, historical actuals is usually, one of the better ones because it's validated. It's something you've produced in history. You have your parametric or CER, largely what we're talking about today, the learning curves based on your data. Analogous estimates similar to a program using complexity factors and things of that nature, or engineering or expert judgment, which is typically lower on the scale of what's substantiated. So looking at this slide, this is kind of looking at your level of acceptedness or how good is it, right? So from the lower level that is red, an estimate that is unsubstantiated by any supporting data, oftentimes which engineering or expert judgment is typically not recommended, right? So at least try to get some correlated or substantiated data to back up your engineering judgment to at least tell some sort of story. And then an estimate that's supported by comparable data from a similar incumbent program or a validated parametric estimating system is right there in the middle. So notice that it's not really multiple programs yet. So the more data points you get, the better off you are. So which is, why we're talking about data. How can we make data more accessible? And then finally, if your estimate is supported by actual production experience with multiple incumbent programs, you're making these for a long period of time, that's going to be your best level of substantiation. So this is looking at the different data systems that are possible. You have and Fred touched on this, you have potentially sometimes this data is all over the place, right? You have your technical data, technical performance measures, requirements traceability matrix. You have your financial data systems. What we often see is SAP, Oracle, Delta Costpoint. Those are some of the big ones. Your programmatic data, schedule, time phase cost from, your MS Project or Primavera schedules. And then also the material management stuff. And sometimes the material management has multiple pieces to it too, and they're not even talking to each other 100%. So, these proposal data pieces are stored in a variety of different areas, sometimes with limited access. So this makes it difficult to harvest that data from prior efforts and reusing that data. Sometimes data has to be mapped from bill of material structures from one system to the other, and then you're mapping it to the WBS, and a lot of that stuff is manual. So that creates somewhat of a problem. So, running the data from history is quick sometimes, but the mapping and connecting it all together from these disparate systems is really what seems to be, one of the major problems. So the best practice here is to try and at least adopt a method to be able to store that data so that the subject matter experts can query and access that data at their fingertips, right? And make it as easy as possible to translate that historical data into data that can be used on the estimate, along with complexity factors and rationale. So with this, if you're able to do that, you're going to be in much better position to compare similar current and historical projects based on cost and schedule and other performance parameters. So Fred kind of talked to this, and the problem is that, you're kind of flying along and you're trying to do this, right? You're trying to piece this data together, and the engineers are trying to validate their data and run these CER models. But then sometimes there's just no time. They just give up because they're asking for the data, they can't get it, or they get minimal data, maybe just on one project. So they just have to move on, right? And use their best judgment because it's a timeliness thing. You guys are in business, you got to get something out the door. So it's kind of that fight, right? How do I make the data more accessible in a timely manner so I can really improve that cost estimating? And a lot of times we get, resistance from like the actual pricers and whatnot, thinking they're going to be replaced as estimators or pricing people. I think they're only going to, that capability is only going to augment the capability. So you can spend more time on analysis rather than the tedious work of scope definition, costing and pricing, and trying to pull all that data together. So how do we do that? This is a pretty high level depiction of that, but with vastly improved technology and memory and the ability to do cloud computing and web services now, we're able to do this very rapidly. So cloud computing and APIs have made data even more accessible than ever before, and web services that can be used to define, locate, and make these web services available with each other helps us to do things like connect MRP systems, SAP, Oracle, CostPoint, and those systems, your technical data, requirements, traceability, all that stuff we can pull in together into one system so that you're not having to go search all these different systems and you're making that decision making much more rapid. So it's actually should give you an advantage competitively in that environment. So here's just an idea of how something like that could look. Fred mentioned complexity factors. So imagine, having that data, you're able to pull your actual cost data, maybe some basis of estimate knowledge, pulling all this knowledge from MRP, how many quantities, what is the unit pricing, what is the touch labor. So all those pieces that you saw before, you're potentially able to pull together into one unit using this API technology. And with that, you can just search on what you need. So if you're trying to do analogous estimate and reuse historical costs from a particular program, you can potentially just query that stuff and straight reuse it with a complexity factor. And I wanted to ask Fred this question, but I kind of forgot. But it was something to the effect of complexity factors and the use of those. I think he said he's never been questioned on the use of a complexity factor, almost regardless of the basis. I'll just throw that in there. Maybe there's conversation that generates at the end. I know that can be a can of worms potentially, but the key here is make that data accessible. We have technology now. These are multi-billion-dollar companies. We can definitely leverage that historical data to bring it all together. You don't have to do this manually. So then you're able to leverage that knowledge, and now you're kind of learning as a company to reuse that data that much more quickly and use those factors and other BOE attributes that you're storing from a knowledge standpoint. So a little bit about, so this is straight out of the CBOC. So I'm not going to get too much in detail about this, but as Sandy said, if you want to go to the conference, it's great to learn about this kind of stuff. But the idea here is, you want to generate your estimates using these CERs, but then you want to validate it if you can. So this is just a depiction of, potentially raw data that's unnormalized, and then what do we do to clean that up or normalize it. So this might be a depiction of what that might look like. So some of the normalization is based on things like change orders or workforce composition or time between units, things of that nature, where you're showing those different curves there based on those assumptions, trying to bring those assumptions apples to apples with that normalization. So that's what you want to do with that data to then go and validate your learning curves. And this is for, I know a lot of people on this conference know exactly what this is, but I know there are also some people that haven't seen this since whatever 6th grade math class. So really what this is your multiple data points based on some event, right? You're producing something, touch labor for the same commodity over and over at maybe lower quantities to higher quantities or whatever the case may be, and you're collecting these data points. This is what Fred was talking to, and you're drawing a line through it. So this is like you're using these learning curves, right? But then you're getting this actual data. So this is how you go and validate it. And in fact, here, the R squared, I believe Sandy stands for correlation or something to that effect. So that's a key thing you want to look at when you go and gather this data, I don't know if you wanted to talk to that, but that's some of the things you wanted to look at.
Yeah, that's close enough, Tom.
Okay. All right. So what are we after here? One of the main points here is trying to get your company to get internally driven CER data. So, there is a framework available where you can go and get your data and develop your own estimates and forecasts. So here's just a depiction of, maybe an input of quantities by period of some commodity or something you're trying to produce, right? So the idea here is you input units of production as the quantities as the independent variable, and the labor hours are the dependent variable, depending on, that data that you've collected. So you're kind of storing these data based on these models and having the input or the units of production drive the output learning hours. So that's kind of the idea, is to make that more accessible and standard based on those models for your end users or your knowledge workers. We know the cost estimators know how to do this, but the problem is pervasive oftentimes with the engineering, and just getting them kind of a quicker, better way to do this kind of stuff and not having to rely on the analyst all the time. So maybe the analyst could be kind of doing the work in the background, but they're giving access to it that much more quickly to the end user, to that knowledge worker, because the data is more accessible. It just helps everybody out. So what are we trying to achieve? We're trying to achieve creating the ability to input quantities by time periods, and automatically as the case may be, and there might be some analysis that goes on here. Per your recent CERs, you're sort of maintaining those CERs, but the idea here is you can almost, once you've done that analysis, real time input those quantities to generate your inputs based on those learning curves. So again, I just wanted to make this clear, that our target really is the SMEs, the engineers, the solution architects, the developers, and the knowledge workers. So we want to get it into their hands, right? That's what really makes the power. So the cost analyst should oversee which learning curves get applied, ongoing analysis of the data. However, this model provides cost realism through the use of internal data and learning curves. So that's kind of our target audience in this case. Just a quick point about homogeneous items. Just something that I've seen is a lot of times there's a requirement or a request to say, what's apples to apples? And sometimes the companies that we deal with are trying to rely on a WBS name for commonality or even task names. And engineers almost every time, unless you're operating to like a mill standard 881, but we all know that always gets extended and changed. There's no codification, right? And an engineer is going to name something different than the next engineer almost every time. So it's similar, but there's different spaces and might be a different, part of the name. So we found that just the best practice is to create a code of accounts and tag those WBS items and or task items, and don't rely on the standard codes to standardize. So codify your homogeneous items to the best of your ability to make that all work. Just something we recommend as a best practice. Unless you can get your WBS so standardized that it doesn't matter. I haven't seen that yet. So the point here is we can use AI, and it's AI, and I use that term loosely, in that we're building up a model where we can use software and coding to identify these learning curves based on what's actually happening. Now, it's not completely artificial intelligence, because I know Sandy would argue that, because there's still some intervention that would have to happen by the analyst, or somebody's going to have to maintain that that item when that bill of material changes and update that model. But you can automate a lot of this and make things easier from a standpoint of that normalization that Fred talked about. So what might that look like? I can do something like establishing a shareable estimate component and methodology library that provides consistent, repeatable, fast, and accurate estimating. What we call it is a process library, but really the idea is getting that, whatever that commodity is, in this case, it's an engine unit, down to one unit. What does it take to build out one unit, both touch labor and bill of material items? And then you can see here, we can apply a learning curve to that item based on what you're trying to do. But there is work that has to go into this. This doesn't just happen by itself. You either have to do the analysis by yourself or have somebody help you do that to get those numbers. So just in our process library, the idea here is that we could tie bill of material and labor into that normalized one unit. That's kind of what you usually want to start off as a base, and then drive that with some sort of learning curve. So that's just a depiction of that. And then, you know, think about if you have like maintenance items, because I know a lot of times you have recurring stuff where you're, you know, maintaining an HVAC. You know, I know if you're building an airplane, you're not doing that, but there are repeatable work pieces where if you could have something that has duration and frequency based on that base set of normalization, you got to do this 3 times over a quarter for the next 5 years. That's what this methodology is showing, just being able to use those multiplication factors to get those easier answers, so that your BOEs are really kind of more traceable, and you're not doing this, you know, kind of off the cuff in Word, and there's no traceability to it because those numbers get all over the place. So if you have a model where you can have those inputs and have them kind of locked down and they're repeatable and traceable and the bases are all there. So if I go and update this from 5 quarters to 6 quarters, I'm not doing it in Word, I'm doing it mathematically. So all that ties together, right? So that's kind of a key component. So really what we're after here is that traceability and standardization. The last thing I want to talk about here is forecasting. I know Sandy already mentioned this. There's no difference here with the learning curves and forecasting. I just bring it up because we see, and this is an organizational problem that I see, right? You have your business development, your cost estimating teams go get the job, and then it gets thrown over the wall to a project manager. That's what I was for DDX for years. And I would get this ball of, you know what, I didn't even know what to call it because none of the engineers knew what the heck it was. But, you know, that's a whole nother story. So the point is there's organizational breakdowns between the estimating teams and the people delivering. So you want to kind of think about that. But forecasting here, this is just a simple learning curve, as Sandy kind of mentioned, raising something to an exponent. So I just wanted to point out here that if I start off with the first unit at, for example, 22K times 4, that typical answer, most of the times what you see in a forecast is 88K. But if you can apply a learning curve at 90%, you could see that value is more like 72K. So I have never seen this kind of maturity in forecasting anywhere, and I've been around a long time. Maybe it happens, I see it more on the cost estimating side, but in forecasting, it's like, hey, how many, we're lucky to even say, you know, how many units we have left and kind of identify close enough cost, let alone learning curves in this area. But it does apply, right? So it is helpful in the project execution side as well as the cost estimating. And then same thing with the forecasting, the production breaks can also apply just because you estimate something as a straight 88 set of lots, or you know, you're going to deliver this 88 times or ship sets or whatever, doesn't mean the production breaks aren't going to happen. So on the forecasting side, you want to be prepared to do this as well. So for example, if we had like a retooling at the 84th unit on this airplane, right? You want to be able to use that production break at that point to provide that new learning curve on the 85th unit, because that's where it happened. The major point here is the project execution teams that I've seen that I've seen in my experience don't rely on any of this stuff. So the idea is would try to get it in their hands, into the, the control account manager's hands, the program manager's hands, the knowledge worker's hands, so that, we're just better at estimating, whether it be for a proposal or whether it be for delivering a project at that point. So this is just really, I'm not going to talk about this too long, but this is a ecosystem where you could potentially bring in your actuals, right, and relay it back to your cost estimating and interface with that. This is really the idea of bringing all your data together in one system in a collaborative fashion, so that you can do things and query things from those disparate data systems and reuse those internal cost estimating curves. So with that, I'm going to have Sandy try to bring this all together with an actual example of live data.
All right. So kind of running out of time, but I'll do this quickly, and we got to transition as Megan's got to bring up some spreadsheets on her screen due to some Zoom issues, and then I will control from there and show you an example. So basically, I guess, Megan, are you working on that?
I need Tom to unshare.
Okay.
We practice this.
Yes.
Yeah.
Okay. So the data you're going to see is from a sensor system that went through EMD, and the whole idea of the forecasting model was to forecast LRIP and then potentially full rate production for the sensor system. So what you can see on the screen here, this is SAP data, summarized SAP data. For those who know about SAP, for major companies, SAP collects every hour for every charge number that you submit, every cost for every part that you sell or buy, it goes into SAP. So there's a tremendous amount of SAP data that us cost estimators would be overwhelmed to do anything with. So you got to work with the IT and your business management folks to write reports that will summarize your data into something more useful, which is kind of like monthly data. If you can see, this was summarized into monthly data, and you have cost in hour data. So I used some SAP data, and then there was some other financial data that came from more of the project control data that sort of also feeds SAP, or is actually maybe derived from that for business management. That's some CLIN hour data and some CLIN cost data for the EMD program. So really, when EMD, you got one or two engineering units of data that you then have to magically forecast for your low rate production and full rate production for either budgetary purposes or for submitting a proposal. So I end up taking all of the actual data, doing a bunch of stuff on a bunch of other spreadsheets, and I call it my data transfer sheet, where I create I know there was some question about 881, and this is a fairly 881 WBS, where I break out hours and dollars into the different WBS components. And so this is just all accessing the raw data or summary data from SAP and the financial system. And then I build a production model from the data transfer. So here's your data, and I won't go through all of it. This is a very parametric data model, and where I can put parameters on learning curves. That's the inputs here on I have a whole parameter sheet, and since we only have one data point, you would use your historical learning curve or cost improvement for these different components that you would estimate from other programs in your factory or plant or however. This is just all set for 100% for simplistic reasons at this point. And then in reality, it all comes down to building your models. So everything in black are equations of either different types of applying learning curves. They're fairly complicated formulas, or there could be some economic order quantity factors for material. I think he was down here under the hours. So this is more of a learning curve. And then there's some program management stuff that you're going to have some LOE. So you can, this is just an example of using structured lots of data, putting it into a usable WBS, and then estimating all of your different components. So I think that's kind of it. And so I think now we'll just kind of open it up for like 5 minutes of questions. I guess, did you find any good questions in the chat, Megan?
We sure did. We have 4 minutes for questions. We know everybody's probably got a 1 o'clock, so we're not going to poke over onto your next meeting. There was a question I think that got answered. So the chat's been lively, guys. Thanks to everybody for answering questions as we went. There was, I think the one we'll get to is from Stuart Spalding. In applying analysis of historical data to develop support ratios and learning curves, and then applying it to a new project to estimate, how do you address a change or difference in the make/buy split between the historical program data and the new program data?
I guess I'll answer that one because I've done that before. Yeah, that gets really to, Fred, essentially your adjustment factors are what we call complexity factors. So you have historical for one program and you're applying it to a new program. So you know there's differences. So you're going to have to come up with the operative is a good story of how what you did before applies to the new thing. And a good thing is like number of drawing counts. So if one program had 100,000 drawings and the new one you think is going to have 120, so you could have a complexity factor of 120 over 100, so it's an extra 20% type of complexity factor. And you could do it at lower levels if that made sense versus a high level. Anybody else want to add to that, or I think that?
No, I think you covered it. Thanks.
Okay.
All right. Then with no further comment, we'll move on to the next one. Supplier material cost. How much do people use learning versus EOQ approaches for that effort?
Well, I guess I'll take that one again. It all depends on your supplier, whether you think that they're going through some learning or you're talking to them and they're actually giving you EOQ breaks. So in a proposal situation, you'd be talking to your suppliers and you'd be asking them for historical data as you've sent them an RFP and they give you a quote back, and you're going to do your due diligence and evaluate their proposal back to you. So sometimes you're going to see if it's an EOQ, if they said, okay, if you buy 100, we'll give you a 10%. If you buy 200, we'll give you 15%. Or it could be based on a learning curve where they essentially give you a rate schedule. The more you buy, the cheaper your price is.
All right, with 59 minutes past the hour, I'd say it's time for everybody to give their closing comments. So Fred, Tom, Sandy, do you have anything you would like to say to our lovely audience before we leave them for the day?
Just was an honor to have the opportunity to talk about a subject that I think, whether we like it or not, we're all faced with on a daily basis.
My only comment is hope to see all of you in Minneapolis in May.
Yeah, thanks very much for joining us. This is something we deal with on a daily basis. So I thought it was a good topic, and you know, accessibility to the data is something that we try and solve. So I appreciate y'all joining us, and like Sandy said, and Fred, hope to see you at ICEA.
Awesome. Thank you, Tom. Thank you, Sandy. Thank you, Fred. Thank you, everybody, for joining us today. Looking forward to seeing you in Minneapolis. Thanks again, everyone, and enjoy the rest of your days.
Thank you.
Thanks. Bye.